Welcome back, everyone, to theCUBE's live coverage here at Supercomputing 2025. I'm John Furrier, host of theCUBE with Dave Vellante. The show's about AI infrastructure and the speed and the reliability is enabling agents and all kinds of world-class applications on top. We got a great session here with Solidigm. Steen Graham is the CEO of Metrum Ai. Steen, great to see you.
It's always great to be here.
Ace Stryker, Director of AI Ecosystem Marketing with Solidigm. Great to see you. Thanks for coming on.
Hey guys, thanks for having me.
Supporting theCUBE, really appreciate it.
Absolutely.
Not much going on.
Solidigm, you guys, your booth is crushing it here. Great display. Congratulations, you guys are doing extremely well.
Thank you. Yeah, the team did a great job pulling the booth together. I encourage folks to check it out if they get a chance.
You know, the word extreme co-design has been kicked around by NVIDIA. Jensen Huang has kind of uses the word extreme, but co-design is something that you guys have been doing. You had great success. Talk about the key things you guys are showing this year in the booth and what you guys are demoing.
Yeah, there's a few demos going on in the booth. The one that I'm personally most excited about is the one that we worked on with Steen and team at Metrum Ai. And what we're doing in that demo is we're showcasing an actual AI inference workflow running in real time. It's a video intelligence demo. And so you upload some video, you run it through an AI pipeline, a vision language model, large language model, sort of parse what's going on in the video, generate clips of specific points of interest depending on what you're looking for in the video. And what we're showing off from a hardware point of view is, hey, a lot of times this is done in memory and you're trying to cram all this into the system DRAM, which is a very expensive proposition. But there's some technologies that Steen and team have put together where you can offload a lot of that data to high performance SSDs like the kind that Solidigm makes. So it's really a TCO story. It's about doing this kind of inference on really data intensive sources like video sources. Yeah. And saving a lot of money along the way by keeping some of that stuff in NAND as opposed to DRAM.
You guys have done a great job on the product side. Steen, you've been really working on this for many years on AI optimization, AI performance, efficiency. Give us the scoop on the core things you're optimizing for. What are you focused on?
Yeah, well, I think like at the advent of transformer models, 3 or 4 years ago, we were just really focused on getting state-of-the-art models in GPU memory and getting high fidelity results that didn't hallucinate. And I think as time has evolved, as you guys have seen, the cost curve for affordable models is kind of at a peak hype, and everybody's trying to reach profitability. Everybody's looking for cost optimizations, and obviously you can distill models, you can choose small language models. With the advent of systematic software like RAG and multiple agents, there's so much systematic code around the models to improve the accuracy and add these workflows to enable these agents. So like now you're kind of thinking at a much broader level. Even for, what was traditionally like an inference workload with the chatbot is a much more sophisticated multi-model system with agentic calls and tool usage. And that's kind of when you start thinking about these things like, hey, what if we offloaded, our vector database, and indexed, in the solid state drive? There's terabytes of memory there. Where, when you're just looking at the system DRAM memory, your footprint's dramatically lowered. And, can you do something like that and still get the performance you're looking for and the accuracy you're looking for as well? And so we partner with Solidigm to make that happen and, kind of showcase that you can run some of these state-of-the-art workloads and offload them into non-volatile memory instead of kind of placing those in volatile memory.
So let's talk some more about that, because when we first met several years ago, we were, hey, these called scaling laws, and it's freaking blowing our minds. And then, we had one shot, and then we get into reasoning, and you're talking about agentic and RAG-based chatbots and multimodal. And so how has your work sort of changed? Because you were always there trying to solve that efficiency problem. So now you're saying you're attacking this with sort of offloading the vector into a sort of larger storage pool. Can you be more specific about that? Add some color to that, and what else are you doing to drive that efficiency?
Yeah, so I mean, the North Star is always accuracy that drives business outcomes and, generating that TCO story. So from like a product perspective, you're always focusing on how I can deliver the most accurate product that, saves the most time, delivers the most top line revenue results. But when you kind of back into that you want to do it in an affordable way. Because as you guys know, if you look at the compute infrastructure costs, it can come out really affordable, especially if you're looking for that high accuracy solution. And so you start making all these design decisions that include the network and the system memory. And so, normally we would just use all the DRAM memory, get the best performance RAG, agentic RAG application, because you got to give those agents a knowledge bank. You kind of do that through the RAG process. And then, but now with like the disk ANN algorithm, which is a great open source project, you can start optimizing through the disk ANN algos on the solid state drives, and you get like near same recall performance, near same accuracy performance, and you can increase your queries per second, all while seeing a dramatic reduction in your DRAM usage. So now we're kind of hitting that cost curve point in AI where everybody's thinking about profitability when you deploy these solutions in production, and that's where you can kind of use some of these state-of-the-art techniques to lower your overall costs. Now, obviously, DRAM prices are just, I mean,
now the enterprise,
right. Well,
the roof.
and we're just even recently, I mean, of course, we're hearing, next year is going to be a tough year in terms of just procuring DRAM and what it's going to cost, right? I mean, you guys are in the middle of this, so how do you hedge against that, and how do you see that playing out?
Well, I mean, for Solidigm, it's only a good thing when we've got more data that needs to get stored somewhere. Right? And so, of course, we want to help customers be able to do that efficiently. Part of that is just, maintaining a level of performance that's required by these AI workloads and kind of maximizing for affordability, right? And there's technologies like QLC that help us do that. You can store more data, more bits per cell, and get to these really, really big single storage devices, like 122 terabyte SSD. But the other part has to do with kind of zooming out, right? And looking at things, not just in terms of the storage device itself, but at a system level, how are the components and the resources working together, which is really at the heart of the work we're doing with Metrum, right? The central question is not just, can we optimize the storage subsystem, but can we do more with an SSD than folks are generally thinking about, right? And can we take some of that stuff that happens in memory, which is, dollars per gigabyte, and move it onto NAND, which is, 5 or 10 cents a gigabyte in a lot of cases, right? That can have meaningful...
The cost curve, you guys talk about the storage wall and then the cost curves.
Yeah.
On the enterprise, it's a very finicky market because they have smaller models. They want to get the accuracy. They don't have a big CapEx budget like the big hyperscalers dropping $20 billion for another data center. So this is where the model tuning, model interactions happen. Steen, talk about this dynamic, because this is where the design side matters. So for enterprise, beauty's in the eye of the beholder based on what their data estate looks like.
Yeah, and I mean, as you alluded to, like their data center, their power envelope, their existing infrastructure, maybe they have, some legacy Hopper GPUs or L40Ss, or, they're implementing RTX Pro 6000s. The state-of-the-art models are getting up to that trillion parameter, class, and then they're distilled down, and then you make small language model implementations, and that all, generally has an accuracy trade-off, but it has a massive cost savings that you can implement. And I think we've all been kind of working through, these quantization techniques, all at some trade-off. One of the fun things that we did with Solidigm, which I thought was really kind of thought-provoking, is we took a GPU-constrained model, and we offloaded part of the layers of the neural net onto the solid-state drive. So we kept a subset of the hot layers in the model in the GPU memory, and then we offloaded to the solid-state drive. So, where you were previously couldn't load this, multi-100 billion parameter model, now you can load it up if you got a legacy GPU. You're not on state-of-the-art Blackwells or Instinct, GPUs with massive memory footprint.
And that was using standard LRU algorithms, or did you have to invent something new to implement that?
It's kind of like, kind of state-of-the-art open source techniques that we're leveraging to implement that. So, and it's all stuff that we put out, open with Solidigm, so people can kind of follow along. It's not the most popular technique, but it's a great technique. If you say, I need to run this model, but I don't have the GPU memory footprint, well, you can run it at a little slower pace, because a lot of workloads are running 24/7. Yeah. You can batch the workloads, run them 24/7, get the accuracy recall you need, and leverage the SSD space that you have as well.
And maximize the GPUs for the things that are needed for GPUs. Yep. this is interesting. If you look at DeepSeek, was launched in November 2 years ago.
Yeah.
I remember here at the show, I was talking about DeepSeek. So 2024 was the what does DeepSeek mean? I think you just nailed it. It showed people that you could actually tinker, engineer, whatever word you want to use, to get squeeze the juice out of the power, out of the compute by leveraging things that you already have. And whether it's distilling off the big model, so inference could be very effective. Right, with this. So I guess my question is, now that we're a full year and a half into DeepSeek, almost 2 years since it launched, what's the best practice? Is this kind of a lesson that if people walked away with, like, hey, I can use the GPUs for monster training, but if I have baby training jobs or edge stuff, I could do other things. And so how does the solid state relationship to the compute and the GPUs relate to each other? Because there'll still be training. I mean, we were talking earlier, like, you can train the big models, but reinforced learning is actually training again. Inference is not going away. What's all that mean? How does that all factor into your analysis?
I think what we're seeing in the market is there's a lot more sophistication in managing the cost curve. Like there's trade-offs when you distill models and you tinker with models and quantize them. So, if all things being equal, of course, us software guys want as much, GPU memory as we can and as much performance. And we'd love to use those training clusters for our multi-agent reasoning-based, systematic software as well, right? I mean, but it's all, there's
you got to pony up some cash.
Yeah, there's a trade-off. So there's just
power.
Yeah, there's much more sophistication right now about hitting that cost curve. And I think, the other thing, aside from DeepSeek is like we've been all super excited about, LLMs themselves, and obviously people really get excited about vision language models, which, with Solidigm, if you go check out the booth, we've implemented vision language models, LLM models, re-ranking models, embedding models. So, and that's just like 4 components of the solution, right? So it's all multimodal just to optimize that accuracy of outcome. And so you can, you start tweaking these for accuracy, and then you hit that cost curve trade-off. And I think, best practices is knowing that business outcome you're driving, knowing what accuracy level you're targeting, and then, optimizing along the cost curve for the minimum kind of accuracy and performance loss that you're looking for. But like just one thing, just adjacent to DeepSeek is like just the massive growth in video usage in AI today, which I think is, you guys were, I think it was maybe 4 years ago, you guys were asking me on stage, like, Steen, what about storage? And, I was like, at the time it was a tough question because this text data is so small. And we were training these models on, a lot of text data, and we're producing a lot of synthetic text data right now. But like once you start looking at, video storage, it's just terabytes. And that's when you have to, you're looking at your 400 gigs of DRAM memory, and you're thinking, oh, where can I offload this? It turns out we can offload it to Ace. He's got terabytes, right? And so you kind of have to think about it when you think about, query and retrieval, into, these massive terabyte data sets of video.
So I feel like every time I talk to you, there's a new problem that you're solving. You're like fighting fires. It's like a game of whack-a-mole, and there's always something new, and you guys are really good at sort of attacking those problems. My question is architecturally, well, how do you plan for that, and what won't change? Kind of the Jeff Bezos question, because there's always going to be something new that you're going to have to find some novel ways to attack. But is there any sort of first principle that is consistent that you've seen throughout the years?
Obviously, focusing on the outcomes and the accuracy is something that just is unrelenting, especially for enterprise adoption. And then, I think that hitting that cost curve, so you enable enterprises to run on-prem their workflows proprietary. That's been stable as well. And then, from a technology stack perspective, it's a great question. I mean, first principles is really you're going to get massive change in innovation, and you have to be on it just every day, every hour, because there's so many talented people that are putting, like, the time from research paper to implementation is dramatically shrunk. And so you have to build, just like we all were taught, like it's all modular software principles. You've got to make everything plug and play, clean APIs so you can just swap it out. I mean, the OpenAI compatible APIs will, kind of allows you to swap a model in a second. And then, the MCP, the tool calls there's a lot of messiness as you're building multi-agent platforms for tool calls as well, but they're starting to emerge as these kind of like foundational tenets you can plan for, but everything needs to be hyper modularized. You always need a microservices mindset on first principles because change is the underlying, item. And, you'll get a customer that just wants to swap a model, not for accuracy, but just because they heard about it that week. Well,
you want to try
fine,
it?
let's make it happen.
Gemini's out, the new version. Let's plug that in.
Yeah. So, okay. So that API consumption model, do you see that as the dominant revenue generator ultimately in the enterprise, the value creator, or do you see something different?
I think, API consumption models, it's fabulous for people like us that just can kind of hook up cleanly to an API. I think the challenges enterprises I think are facing today is they use so many third-party SaaS services, and we've all taught them on how to kind of go to the cloud and use big infrastructure. But they have proprietary workflows, they've got proprietary data, they've got compliance requirements, and when you start running their work with AI agents, and the value proposition is great, there's just so many yellow flags that pop up if you just go hit a third-party API provider and doing that. And so that makes it really challenging for enterprises because it's like, hey, do I go on-prem? Do I start deploying? And, NVIDIA's been pushing the RTX Pro 6000, which we're actually running on, live in the Solidigm booth with the Solidigm drives in it, that GPU and then the server as well. But that enterprise trade-off to kind of go back and be like, hey, our data is proprietary. So we do need to hit these compliance standards, and it will happen easier.
So one of the theories we've been working on at theCUBE Research is the quality of the software on top of that foundation model it could ultimately be a way to address that problem. So maybe it's the quality of OpenAI software. They have an opportunity to build that out, or Anthropic. Yeah. What do you think about that? That they will build that software layer on top, high quality software, that they will be the trusted API source as opposed to, API du jour.
Yeah, when we started building agents and using tool calls and using web search, it was kind of pre the advent of the major AI labs implementing that, but they've all implemented systematic software layers. And, everybody still thinks of the model, and certainly the model is the hero, but there's so much great code that needs to be written around the model to really unlock the potential of
not about the model. You're right.
That's the AI native startups that are coming out. They're building around the models.
Yeah.
Well, guys, great to have you on. Thanks for coming on, Ace. My final question to both of you is, what's the coolest thing you're working on right now?
Coolest thing we're working on right now. There's an opportunity for a pun in there around liquid cooling because we are doing a lot in that space. But looking ahead, I think the other big untapped area of opportunity for storage in AI inference and driving efficiency at inference is really around the KV cache, which we haven't begun to really touch with the current demo in our booth, but certainly on the docket to explore next year. When you have these models with enormous context windows and you have these complex multi-turn interactions, the KV cache can get huge really fast, right? And there are opportunities to offload some of that to SSD as well. So expect to hear from us about that. We'll play around with that in the lab as well. And
it's funny, KV cache a year and a half ago, Jensen said it's the operating system for the AI factory. I'm like, oh, there it is. And NVIDIA's correcting me. No, it's Dynamo. I'm like, okay, all right, whatever. But KV cache, a critical linchpin for all those systems.
Absolutely.
Yeah.
Steen, coolest thing you're working on right now?
Well, the coolest thing that I want to talk about, because it's a plug for tomorrow. You guys have Oregon State and Dell on, and we've been working on some really state-of-the-art solutions in the education sector that's getting a lot of traction. So I'm not going to steal their thunder, but that's going to be a great segment. And one of the things,
give a little teaser. What is it?
Well, I don't know.
Well, Chris was just on.
Was Chris just on already?
Yes, with Spotted Owl segment.
Yeah.
It was amazing.
Yeah.
So you could talk about it.
Well, he's not going to be talking about Spotted Owls tomorrow. He'll have more to talk about on some of the solutions that we're pitching.
But now you're leaving us hanging out there.
But I think, one of the challenges that we're facing is how do we educate a workforce for AI? And I think, if you look at educational institutions, they want students to be qualified and certified and crush the workplace, right? And that becomes more and more hard. Like, obviously we ramped up the advent of online education, but like the fear is, right, am I really, driving the learning objectives of the students? And it's, it turns out that AI, and particularly like multimodal AI, where we're doing like video processing, where if students, present charts with numbers, if they present concepts, if they build presentations, their knowledge retention is fantastic. The challenges of the professor and the administrative burden of going through, hundreds and thousands of videos and grading those assignments, and then grading those assignments in an accurate way, and then consistently, and then with a rubric that everybody buys off on, and kind of an industry standard methodology. And that's something we've been working on with Dell and Oregon State University. And we have, of course, Solidigm drives in that solution that we're running right now as well.
Good plug.
So it's, it's great.
Well, great work you guys do, Ace. Thanks for coming on. Appreciate you guys. This is theCUBE's live coverage, day one of 3 days of world coverage. I'm John Furrier, Dave Vellante, Savannah Peters, and Jackie McGuire is here. The whole team is here. We're unpacking all the AI infrastructure wave here on theCUBE. Thanks for watching.